Welcome to episode 7 of the Luminosity of Free Software. This week we've got three really interesting topics. At least I think they're pretty interesting. I hope you do as well. I've put on my Sousa green tie for this episode just to celebrate that fact. So today we're going to be covering kind of a range of topics: decentralized online communication, Node.js, and color management. Before we get into that, I wanted to note that some people had said last time it was a bit hard to understand the audio, and yeah, I completely get that. It gets a little echoey in the room here, and I'm using the mic that's on my camera, which is not that great, but fear not, I have ordered a proper mic, so I should hopefully be slightly less sounding like I'm coming through the tin can of a webcam. I was also fairly tired last week, so I think I spoke in my unfortunately quick way that I sometimes do when I get tired. So I'll try and slow it down, speak clearly this week, and next week we'll get a, well, we'll see how good the new mic is. So, decentralized online communication. This was actually a topic that was submitted by a reader or a viewer on my blog, and they wanted to hear my thoughts and have a bit of a discussion about things such as Jabber or status.net, the thing that powers Identica, and why is there not more of it, and what is out there. And so what's interesting is I kind of wanted to split into two pieces. One is, there's the technology that's available, and what do we have that can actually provide these services, and the other side of it is, are they being used? So first of all, what is decentralized online communication? Well, we have centralized online communication right now. We have Facebook, we have Google+, which I'm using for this, ironically, and we've, there's Twitter and a few others. And they're these, fairly recent phenomenon, but really interesting in that they let huge numbers of people talk to each other all over the world instantly with extremely, with a huge amount of ease. In the past, sending messages around, I remember way back in the day of my BBS times when we used FidoNet, and getting a message from one place in the world to another was pretty hard. If we go back further, we had to use people to move little pieces of paper around, and that was slightly labor intensive. Well, today we have Facebook, right, and Google Plus and Twitter, and we can just press a button and boom, it goes out to everyone who may or may not care. But they're all centralized, which I think is really interesting. And it's kind of ironic, I think, because the internet is supposed to be, well, it is a decentralized topology, specifically designed that way so that if in time of war, originally anyways, there was 5 nodes on the internet, and the use case was if one or more of those nodes was to suffer destruction, say in a nuclear explosion, which was actually the use case, if you want to call it a use case, that all the other nodes that remained would be able to talk to each other. And at the time, there was no real way of doing this, and analog communication was the norm even between computers, but as they existed then, and people didn't think it was possible, and then they came up with this great decentralized system we have today. Yet, we're using it to centralize our communication. Something that even when we relied on letter carriers to move bits of paper around, we didn't have. Yeah, we had the post office, but no one really prevented you from being just as effective by carrying it yourself or giving it to a friend. And we have DHL and UPS and all kinds of options. Not so much with the Facebooks and Google Pluses and whatnot. So the first question is, do we have the technology to make decentralized systems? So we have, there's a few that are really old, and I don't mean that in a bad way, I just mean they've been around for a while. The first one that springs to my mind is XMPP, which is the heart of Jabber. And that's been actually really, really successful and popular. It's been used by Google in things such as their Google Talk. It's been extended quite a bit. They have a really nice system for creating additions and extensions to the protocol. Very well managed. It's this XML-based thing. Not extremely complicated, which I think is part of the beauty of it, but it works very well. And what's really nice about it is, unlike the alternatives, such as Skype or any of the most of which are dead messaging systems, ICQ. Remember, if you go back even further, was it TomTom or something like this? No, they're a GPS group. I forget what it was. Something to do with drums or something. Anyways, these are very old. But unlike these, you can run your own Jabber server. And I've actually worked in offices where we did this, and it was really, really effective. It's fairly common to do this. And so Jabber is decentralized. Unfortunately, the networks have kind of, most of them have gone away. There's not as much, I think, interest in just text messaging through a specific application separate from the centralized services such as Facebook and Google+. Why? Because you find everybody there, right? But this is still, Jabber is still in broad deployment. It's used especially for in-house communication and really good at that. Then we have another set of tools that are really designed to recreate what Facebook and Google Plus have, namely Diaspora and Status.net. And so what these are social networking, frameworks, if you will, and they're designed to be federated. I read a blog that used the word federated in a way that made me wonder if the person who wrote it knows what it means. We often talk about federated, and we just mean you can, host your own. And if you have your own hosted version of it, then it's federated. No, not really. What federated means is that information stored in one location can be queried or picked up or connected to information in another installation. So DNS is like the classic example. It's a federated database. It's still hierarchical in its data, but everyone maintains some small piece of that database, and it all comes together to answer queries, regardless of where you start your query. So that's what federated is. And Diaspora and Status.net are really meant to be federated. So you can have your own installation of Status.net, have your own Twitter-like place, and connect it with other Status.net. This is actually a really hard kind of problem. And it's kind of neat we have the technology. Of course, we still have the Facebooks, we still have the the Twitters of the world, and they're well, maybe other than Facebook, they don't really seem to be going anywhere or going away anytime soon. And that's a really interesting question. So first of all, I guess maybe I'd like to pose the question that I'll answer. Does it matter? And today, it was going all over the internet, on Facebook and Google Plus and Twitter, of course, that Google was shutting down a lot of their services. They were doing a spring cleaning, and they had shut down their CalDAV API, their calendars, and they were closing the Google Reader, and they're closing the Shopper API, and a whole bunch of things that people were using, and some of which people were using to run businesses with. And this is why it matters, because when a centralized service is used and there's no agreement in place as to what they have to do or when they will do it or won't do it, they're free to make their own decisions. Facebook has been famous for this in terms of their willingness to abuse your right to privacy just so they can maintain, Facebook. And some people see it as an okay trade-off, but it has deep implications for social sustainability when it comes to communication. There's very few things as human as communication. It holds societies together. It's how we create new things. So having centralized services is a very brittle, single point of failure, small group of people deciding the fate for everybody kind of situation. So it'd be nice if they were federated. It'd be nice if Google Plus, for instance, was 1 million Google Pluses that all work together instead of one central system. Obviously, there's benefits to a Facebook, given their IPO, or a Google for having central control over this. But is it good for humanity? I don't think so. there's a real big block, right, a hurdle that has to be overcome before these services will be challenged, and that's critical mass. All of these services rely on the fact that a large number of people use them, and a large number of people are reachable through them. So, if you want to, a lot of people I know use Facebook, for instance, specifically because it has all these people on it that they know. I mean, I don't use it anymore myself, but the one reason I got a Facebook account was because I kept getting asked, "What's for Facebook? Can you add me on Facebook?" And so there's this critical mass issue. And so we've created the technology. The question is, how can we gain critical mass for it? How can we get enough people using these systems? How can we make it attractive enough? And that's kind of a problem because free software has not been, or even just federated services, are not the first mover here. They're second, third, fourth movers, or even further on down the line. So they're coming very late to the game. So they're starting off with small user bases and trying to get enough usage and enough, even just awareness is difficult, especially when every second news show seems to say, and somebody tweeted this, and on Twitter they said this. So it's a bit difficult. I don't really have any answers for this. I think that it shows, the necessity to make free software extremely successful on the server and on the client, separate from the same people who own these large siloed walled gardens like Google. Because they're not incentivated to, if we had the Android platform as a truly open platform for participation, I think that we could really push federated open services like Identica extremely easily by making that the preferred mechanism by which, if you have an Android phone, you communicate with other people. So I'm not sure if we're going to be able to, if we will see the broad adoption of decentralized communication services until there's more independent open source success on the client side. That said, we do have a lot of the technologies in place. A lot of the stuff can be used right now in your business or your school, and it works really, really well. I mean, Jabber is a great example of that. Cool. So I just remembered I should probably jump over into the onto the IRC channel as well while I'm here, because I don't have enough places to watch for questions and comments as it is. So the next topic, I didn't even put the little link at the bottom there. How silly of me. So anyways, jumping from that and to something that's related in my mind anyways in a roundabout way, which is Node.js. So Node.js is I hesitate to call it a application server. I hesitate to call it a web app framework, because it's not typically any of those things. What it is it's the V8 JavaScript engine. Well, that's an implementation detail that is run headless on a server. So you basically get to do server-side programming, but in JavaScript. One of the core concepts in Node.js is asynchronous behavior. So everything tends to be asynchronous, and it produces some really interesting sort of ways of doing things. I've been using it for a year or so, I guess now, on various projects, and what I found, excuse me, and what I found is you can develop extremely quickly, not just because it's JavaScript and so you're not compiling things, but there's a few attributes that it has that just really ease things along. So the first one is their set of packages, add-on packages. Every great programming language or development system ends up with a lot of third-party packages, and if it doesn't really work well. or does it become popular? It's too much work. So I mean, Perl has CPAN, which is like the example. If you're a language, that's what you want to aspire to. It's something like CPAN. So Node.js has something called NPM, the Node Packaged Modules. And just to give you an idea of the scope of this, there's over 25,000 packages listed with NPM. There's around 1.1, a little bit more than 1.1 million packages downloaded a day. And keeping in mind this is server-side stuff, this is fairly significant in size. It's used by a large number of companies. A few examples, Mozilla.org's Persona, their browser ID initiative. Their Persona application is written in Node.js. Yahoo uses it for various bits and pieces of their platform, file sharing, for instance. LinkedIn's mobile app, the infrastructure behind that is Node.js. So it's fairly significant. And so the first thing that makes it easy to work with is just this ridiculous number of packages. The second thing that I find really makes it easy to work with is this whole idea of separate, nice, asynchronous development. So instead of writing these huge applications where all the pieces, you can, if you're very careful and writing procedural code, write your code so it's, your application so it's all very nicely modular and everything's in its own little area, little piece. I find Node.js with its approach to really encourage modular development, where you develop your application in small pieces and the small pieces are put together. So one of the ways that it does this, encourages this, is a lot of people use a package called Express. So Node.js itself is really just JavaScript, and it's got a handful of API, a few things to look at the operating system. It has some API to do raw network sockets. It isn't a web server, but you can very easily, and it's often what it's used to do, set up an HTTPD listener and then speak HTTP back and forth over the network. So it's got tools to do that, but generally the API is pretty slim. It's not huge. So Express comes in and adds a whole bunch of stuff to this, configuration and whatnot. Of course, it's JavaScript, so everything is stored in JSON. And with Express, you set up, if you're doing a network-based application anyways, it allows you to set up routes where you assign paths. So if you're doing a web server, which is very typical, or a web service, you set up different paths from your URL, your base URL, and you go, okay, when this is called, I want you to run this function. And so you end up usually with a file that's got a bunch of routes in it that points in different directions into your code. And this, it kind of very naturally leads you to split your code up and modularize it between the different things you're doing. There's a lot of little kind of good practice encouraging things that go along with Node. They have nice testing frameworks. They've got hooks to run, common tools like JSLint automatically. It's really, really nice. And there's the idioms in it are very simple to get, into. It's not a very deep language, I find, which isn't necessarily a bad thing. I mean, yes, there's JavaScript, which has 8 million strange things about it, and ways to stub your toe. But in general, I find Node.js to be fairly shallow in a good way, in that you don't have to invest a ton of time figuring out how everything gets put together, which makes it really, really great for agile development or prototyping, which I'll talk about in a second. So going back to the NPM package manager, you've got things like Express, and you would like to be able to use routing. How do you do this? So they have this, NPM utility, and you've got a package.json file that you can put in the top level of your application, and then in there you say what all the packages that you use are, which ones, and you can even have different profiles. You can say, when we're doing testing, developer system, these are the packages we need because we're going to run test code. We're going to run our test suites and do performance requirements and whatnot. You can have multiple sets, and then you just go npm, literally npm inside the base of your directory or your project, and it grabs all the things that are in your package.json for you and their dependencies. And then whenever you want to update, you go npm update, and it grabs and checks to see if there's anything new and grabs them for you. One of the things I was very concerned about when we first started using Node was scalability. It was like, JavaScript, can it really be that performant? And it turns out it can. It is, if you look around online, you'll find examples of web services that are serving hundreds of thousands of concurrent users on web services, which is really where I think Node shines, is in web services, which really makes me happy, because I'm not a huge fan of websites that the service is the site, and if you want to use the service, you have to use that one website, and that's the only way you can go about it. So there are some downsides I found with Node. They're totally, I think, offset by the speed of development, the ridiculous number of tools and add-ons that they have for just about everything you can imagine. But there are some downsides. It's very much a web developer's thing. And I have found that web developers have not yet internalized within their mindset that API stability is a good thing. So when you're updating your packages, it's not unusual to find that you go to update on a development machine and certain things just stop working. The API, we found that APIs in packages will just up and change. Usually it's better, but yeah, API stability would be really nice. Now, you can, with NPM, say, we'll use exactly this version. Don't give me the latest version. Give me this one version. So it's not a complete dice roll. But I do find there's a lot of churn. Fortunately, not so much in things like Express and whatnot. The ones that are used across the board tend to be a little more stable. But with the agility in Node, it's fairly easy to keep up with the churn, but it is there. It is also fairly easy to mess up, and your application can just fall over. Fortunately, there are tools that actually run your Node applications, that run your Node application. And should your Node application error out, it automatically restarts it for you, which is pretty cool. As far as support of other pieces on the system, any database you can throw at it, pretty much it connects to. It talks to all the NoSQL databases as well. Web services, colors on terminals. I saw a package that does terminal coloring. So if you're doing output to terminal, there you go. You can have, they even have a rainbow thing where you can say, put it into rainbow mode, and then every letter will come out in a different color, rainbow-like. Yeah, there's just about everything, from the very useful to the less useful, but perhaps colorful. So, yeah, so Node.js, I think there's two really interesting uses for it. One is, I think, more web services. Just forget the website, build a web service. With the Bodega online content store that we've designed for Plasma Active, we're using Node.js in the background. For that, we've started an HTML5 front end for it as well, which runs separately. And it's very interesting because that's all in browser, and it actually talks JSON to the server. We have a touch interface with QML that speaks also JSON to the server. And this seems to work extremely well. And allows you, especially if you're working with things like QML or HTML5, you're already kind of touching a lot of JavaScript type stuff, and really keeps a nice homogeneity between the languages and mechanisms and idioms you're using on the client side. one thing I skipped over about 3 times here. I mentioned earlier that a couple times that Node is it has this real asynchronous nature baked into it. On the downside, which I didn't mention, is it can be a little bit weird to debug such applications because your application can be doing all kinds of things simultaneously. So that's a little bit difficult at times. But it is kind of neat because there's a really neat idiom where what you tend to do is create callbacks, and you call a function to connect to this this online service or fetch something from the database. And the last, and this isn't a requirement, it's just an idiom within Node, the last parameter tends to be your callback. And then your callback gets called with an error as the first optional parameter, and then other parameters thereafter that might be in the database would be for instance, the result set that you got back. So yeah, it's a really interesting sort of way of going about it. I definitely recommend it. It's not a 3-layer system. It's not written in Java, which is I guess a benefit. It's not PHP either, which I find can be overly tricksome to use. And so it's not the end-all be-all, but I think it's better than a lot of other options out there. Definitely take a look at it, play around with it. It's great fun. And I think for people working on desktop applications that are needing to interoperate with or use online services, I really think because it runs so easily on a local machine as well, I think there's a huge opportunity for building test services that just spit back you say, well, I would log in and then I ask the web service for, I don't know, the weather in Rome, and I should get back. And you can build these dummy services extremely easily, extremely quickly, and then you have complete control, and you can see what's arriving on the server side. You can send back ridiculous data, bad data, increase delay times, etc. And so you have a lot of control. And I think it'd be a really nice kind of development tool for desktop and mobile applications that are meant to be used in online services in terms of development, a development tool, as opposed to hammering the actual service over and over and over again. Okay, enough rambling about Node.js. And I should take a real quick look, see if there's any comment eddies. Before I switch topics real quick. No, good. Well, actually, Ivan was mentioning that it works really well with CoffeeScript. And yes, it does. Node.js really, I mean, the guys who do it are on kind of the cutting edge of JavaScript. And so whenever there's something cool with JavaScript that comes along, like CoffeeScript, you tend to find support for it. So on to the next topic, which if I can find my Hangout toolbox again, and I can switch the little topic thing. We're going to talk about something that I found extremely, I had a basic inkling of how it all worked and how it went together, but as I started to look into this topic more, I was like, wow, this is extremely complicated, and that is color management. So, deep breath. What is color management? So color management is a pretty simple concept, right? You have a screen, well, I'm looking at one right here, I have a printer over here. I've actually got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different screens on my desk here. They don't all, shockingly, output colors exactly the same way. And if you're doing artwork, if you're doing print production, if you're doing anything that you expect to look the same on this screen and to print out and look the same, or I want to design some graphics for a game on my desktop and then I want to play it on a tablet, am I actually getting the colors that I think I'm getting, or am I just getting the colors plus some sort of distortion based on my screen? And that's because screens and printers don't all output colors exactly the same way. they may show that same, I mean, in behind the scenes, it's obviously the same data. If you use RGB as a color space, you got the same RGB values. But because they're physical devices, not pure mathematical devices of perfection, the output can be different. And so color management is designed to try and bridge that gap between the theory, which is the actual color data that sits in your computer, and the practice, which is what comes out. And this is particularly important and tricky when it comes to multi-device workflows. So, for instance, designing the graphics on a workstation for a game that's going to be played on a television, or doing a layout on my desktop and wanting it to print on my printer, but then also the printer downtown with the same colors. So I'm actually creating what I think I'm creating. It turns out that there's a huge amount of free software around this topic, which is really, really, really cool and nice to see. So there's, I'm just trying to find where in my notes I found a really nice set of definitions. There it is. Off of the Argyle CMS website, CMS color management, not content management. So there's 4 really core concepts that they outline. One, device link, abstract, and named. The abstract and named I found a little abstract, excuse the pun, but basically they're ways to define color spaces, and a color space is given a set of color data, how do you actually encode that into numbers? What's more interesting, and where a lot of the work and what you and I would probably see from a CMS comes from, is the device and device link pieces. Device is, in color management parlance, is the bit that takes the color data and is able to translate it such that it actually appears on the screen or in the printer as it's supposed to. So basically it's kind of fudging between the error in the output and the pure mathematics of the input. So it's a translation. And then you have device links, which is simply doing this multiple times. So let's say we have one set of color data. We've got a monitor that needs a correction in this direction. You have a printer that needs a correction in that direction. Then mathematically, you can say, okay, if we go from the agreed color data, here's how we transform it to the screen, here's how we transform it to the printer. You can then use that to find a way to transform directly from that screen to that printer. So that's called device link. And that's basically what color management systems do. Pretty simple, right? Yes and no. So in free software, the most important tools, they're not the only ones, there's a lot of them, but the most important ones out there appear to be the little CMS, LCMS, the Argyle CMS that I mentioned, and they actually don't do quite the same thing. Argyle seems to be a lot more about, although not exclusively about, but about managing these profiles and defining the device links and whatnot. And Little CMS seems to be a lot more about, though not exclusively about, actually doing the transformations. So using those profiles to modify the color data so it appears proper on screen or print or whatever. And of course, one of the kind of bit to this is that all of this needs to be stored in configuration data somewhere. What is the transformation between screen A and printer B? And this needs to be stored somewhere that applications can get to it. So where does it get used? Before I go into a little bit more of the glue bits, Krita uses it, as does, pretty much all of the high-end, nice graphical applications use it. The LibreGraphics suite, essentially, all of them use CMS of some sort built in, and most of them, it seems, use LCMS. Apparently, LCMS, I'm not an expert in this, so I'm taking other people who know what they're talking about word for it, but LCMS is actually considered the best CMS out there, second only to Adobe's own proprietary one they've been developing for years. I mean, that's kind of what Adobe, at least in the past, that's the reason for being. So I think it's very impressive on the part of the LCMS people. There's a few others as well besides Argyle and Little. One such as the OpenIO, which is more in use in the film industry, and that's actually maintained by companies in the film industry, which is really, really cool. So we see it used in things like Blender, so that you can not only accurately get your colors, but adjust them. So, I mean, every movie these days comes out and it's been color processed. Yeah, not always to good effect, I think, but color management systems play a role in that. I mentioned Krita. When you want to actually do art that you're going to print into, say, a comic book, as some of the people that use Krita do, you want it to print properly or show up, on the Android tablets that are going to read it properly. And so the CMS is used there to do that. But we also have full screen color management, and window managers such as Quinn can actually do full screen color correction. And I'm actually using that right now. And it's funny because I didn't actually realize, because I hadn't set up the CMS stuff before this. There's a project called Color Manager, I believe, and it's with a K, so it's in the KDE project, one of those. And they provide ways to configure one of the two main kind of top level of the stack tools called Oyranos. I believe that's how it's called anyways, Oyranos. And it sets up the configuration. You can also do calibration and whatnot. Now I'll show you what it looks like here. And get the screen share going. Screen share is like the slowest thing ever. And waiting for it to let me to select a window. Oh, there we go. Nope. Oh, there we go. Good. So here I have the control center, the control module. For it. First I'll go to the colors module, discard that. And I'm using the oxygen color scheme here. And if we go to the window background, it's slightly red. There's a little more red, and I never realized this. I thought it was just very gray, but it actually has a slight pink tinge to it. There's not so much blue. The green is kind of in between, and then a little bit more red. It's kind of warm, which explains suddenly why there's also a oxygen cold. That's primarily the difference, is this lack of pink and red in it. On this screen anyways, on the internal screen on my laptop, you can actually see it better than on the screen I'm using, which is a Samsung something or other. SMEX220 or 2220. Now what's really cool is Oyranos knows based on the EDID of the screen what it is. It also knew exactly what kind of printer I have, and so I didn't do any configuration here. I just installed the Color Manager project and started it up, and this is actually what I saw the first time I started it up, which I think is very impressive. So what it allows me to do here is select, for instance, this monitor, and it downloads actually from TaxiDB, which, as I understand it, is actually, it can fetch things from online as well. And it'll grab profiles, pre-built profiles. So you don't have to have a piece of hardware to actually calibrate your hardware, which you can also do. So you can adjust for things like custom gamma and whatnot. Or if you're in a very bright room with strange lighting, the stock color profile may not visually match because the environment what it should. But generally there's just hundreds, probably thousands of these profiles preset, and you can pick them. So originally, when I first got it, it was actually set to this one. I don't know if you can see the change that just happened. I hope you can, because this is the wrong profile. And this is what I was quite used to, was this slightly washed out result. And I didn't know until I hit this just how much red there actually was in the default Oxygen color scheme. And so I instantly got this rather nice improvement. And at first it was a little jarring. I was like, I'm not sure I'm going to like it because it's all of a sudden very red. And then it took me about 30 seconds and everything felt warmer and nicer. And I think that there's probably a Nuno Pinheiro out there that is turning in his grave and wanting to smack me over the head and saying, why didn't you do this years ago? Fair point. So this is the difficult part for the user, which is setting up your profiles. And really, you just click on the device and pick the matching profile. It's very, very simple. And what's nice is if you have different monitors, such as an internal laptop monitor and an external monitor, you can actually get them to match each other. So suddenly they show the same colors because each will be adjusted to the same internal color spec. There's also this settings dialog, which comes with it. And I honestly, I don't have a clue about any of what's in here. It talks about things like editing labs and XYZ. I do know. This is the color space. It's a standardized color space for the for color management systems. It's an ISO standard, I believe, and of course CMYK and RGB. Oh, LAB, of course, that's a color space. Yeah, it just occurred to me right now as I'm looking at it. And so you can actually customize all of your color spaces here, or as they call it, profiles. And there's all kinds of behavioral things you can do. To me, this is stuff for people who actually, rely on it for artwork or whatnot. The pro users. Me, I just want my monitor to show that nice glowy red that it just hints all of the Oxygen colors. So that is what you can do with color management. And it's really cool because until very recently, we didn't have color management in most of our applications. So having this in the Kretas and Blenders of the world, having this in the Plasma Desktop or the Plasma Workspace's window manager, Quinn, is cool. In fact, watching right now is Martin Gracelin, who apparently has never seen this actually in action on his machine. He just knows it connects into it. So Auranos is not the only tool. Now, Auranos sits on top of tools such as Argyle and LCMS, or works with them anyways. But it's not the only one. There is one other one in the free software world that is comparable to Auranos, and that's ColorD. And that one is actually also the guy who's behind the ColorHug, open source hardware to do color calibration, is also involved with, well, he's the primary developer, I believe, of ColorD. The ColorHug does work with Argyle as well, so you can do the color. You don't need to use ColorD to use the ColorHug, for instance. But it's very cool that there's open hardware to do this as well, and it's just this little thing that you press against a screen or output of some sort and go, okay, count the photons for me and tell me if there's enough red, green, and blue in them. And then it generates a very accurate, calibrated version of the color profile. ColorD and Auranos take very different approaches. So right now, ColorD is the only thing that's supported by GDK. There's support for it in CUPS, the print service. This actually is problematic. I'll get to that in a second. So that's more or less where it kind of goes to. It stores its configuration in dconf, and it has a dbus API. Auranos is, well, they're talking about adopting maybe even the same dbus API, which I think would be fantastic. They don't use dconf, they use their own configuration system. They're not integrated with GDK right now, I don't believe. But what's interesting is that Orinos has a lot more features for actually doing color space transitions, so you don't have to develop all that code yourself. It's really a one-stop solution, whereas ColorD is really more about the configuration and setting these configurations around saying this is the spec you should use. We're going to go from this device to that device, or just from data to this device. Here's the profile to use. So a good example of this is Sane, the scanner library. With ColorD, you can get the profiles, but then you actually have to do all the color application yourself. So you have to use something like LCMS. With Orinos, it actually can help with the entire side of it. Now, as I mentioned, ColorD is in cups. Unfortunately, ColorD is really based around sessions. So in terms of user sessions, which is perfect in a single user environment. But as soon as you have a remote printer, or if you have a printer on a multi-user system with multiple people logged in, but viewing it from different screens that might have different profiles, the screen to printer fidelity is not going to work anymore, because it's all about local user session. So this is actually a place where it needs to move to what actually macOS 10 does, which is put what's called an intent file into the print job. So you print out the data, and then you actually include in it, here is the transformation that needs to happen, because this is what we were showing on the screen, and this is the printer it's going to, here's my intent, now apply it. And so this is actually probably going to land in, as I understand it, in Qt 5. It's what Orinos people are working on as well. I don't know, wasn't able to find any information about ColorD and what their plans are for this, or if they're just happy with the single user situation. So it's a little unfortunate that we have two solutions for this level. I mean, I think it makes sense to have Argyle and LCMS. They, I think, are really complementary. But I don't really see the point of Orinos and ColorD. I can see benefits to both, and I can see drawbacks to both. At the end of the day, I have to say I am kind of just happy that I have a color managed system. And it was really quite easy because I'm using OpenSUSE here, and they had all the development packages for LCMS and Argyle and pretty much anything I needed directly available, and I just zipper installed them and then built the color manager from Git, because that's what I do. And yeah, I now can see a slightly rosy tinge on my screen, which is really, really pretty. Great. So that brings us to the end of, as Daniel Nicoletti mentions about ColorD in the printers, it's really about the printer dialog to do that. GDK just asks the profiles and sends it with the job. And yeah, that's exactly what needs to, what needs to happen is it needs to be an intent file that gets sent along with it. Yeah. Good. Let me just check really quick on both the IRC channel, which is very quiet. There's people in there. And I forgot to pull up the YouTube channel, because obviously that's important. See if anybody's saying anything there. And so far no. Good. So we'll move to the question and answer period section of the show. And so really, really quick, Tom asked, could I explain why there is no real decentralized encrypted P2P file sharing and messaging tool in the standard KDE software compilation installs? He says, I think such a tool would be very valuable to pretty much everybody, especially those who live in oppressive countries. And this actually, I think, really fits in well with the decentralized online communication topic at the top of the show. So first of all, we're actually trying to have fewer applications in the KDE software compilation and trying to encourage more usage of extra gear so that there's more of a universe of applications. And we don't try and create that mythical one set of application fits everybody. Yeah, a console, a file manager, a text editor, a few of these things we can take for granted. But things like decentralized encrypted P2P file sharing, not necessarily going to be useful to everybody, but I do think it would be something that would be very good to have in Extra Gear if we don't already. We have a lot of encryption tools that work with GNU PG, both things such as Contact with its ability to handle encryption, but also KGPG and such tools. So yeah, it's a really good question why there aren't more tools for things like Tor and whatnot. And all I can say is it would be great to see people get involved more in those kinds of things. But I don't think they'll ever end up in the main centralized releases. In fact, I kind of suspect that with Frameworks 5 and Plasma Workspaces 2, we're going to start to see more decentralization of the applications as well, which I think will actually make it more inclusive. And some of our best applications are in Extra Gear already. Or in suites like Calligra that have their own release cycle. A GUI asked, with Plasma Workspaces 2, you'll be able to run both Plasma Active and Plasma Desktop on the same device, and thus have both active and desktop applications available. Do we intend to have every type of application available everywhere, or will you only have applications suited to the current shell? It's a really good question. So what we do already in Plasma Active is we only show in the launcher applications that make sense in that environment. We don't prevent you from launching other applications. You're free to do what you want, and we don't try to get in the way of that. But we present by default the applications that make sense. And conversely, on desktop, we already show Okular instead of the active version of Okular because it makes sense on the desktop. Something that we are working on, though, and what will come in Plasma Workspaces 2 is the ability to detect runtime changes. So right now, already, if you run your application, and we actually have some apps that do this now. If you run your application and it's written in QML and you're running on desktop, you can adjust to being desktop. In fact, if you're running as a windowed application versus something on a desktop or a panel, you can also adapt. So you can have an application form factor. You can also know whether you're running on a touch device versus desktop with keyboard and mouse. And you can adjust your UI presentation at runtime. Right now, however, it's a one-shot deal. So when you start the application, that's what it looks like. There's no particular reason, however, why we wouldn't be able to switch that at runtime. Right now, it's already done in an environment variable, and then tell the application, please reload your UI so that's appropriate to the current new form factors, or what we call usually the runtime environment. And so we plan on doing this. We need this for Plasma Desktop to Plasma Active switching anyways. We should have the one desktop shell, and we're not going to restart Quinn if we can help it at all. So what we want to be able to do is have something that says, right now we are desktop. And then when a hardware event, such as a docking happens, or an undocking, or you plug in a keyboard and mouse, or whatever it might be, or the user says, please go into, I want to turn this into a media center device, then at that point, wherever that bookkeeping is kept, it will say we're switching to this new form factor and then broadcast that. So any applications can adjust. Quinn will need to do this to adjust its configuration. Obviously, if we move from, say, Plasma Desktop to Plasma Active for touch, you're not going to want window borders. They're superfluous. Everything runs full screen or maximized anyways. So, and Plasma Shell will also need to do the same thing. So yeah, that I think is really interesting, because then we can actually build true hybrid applications, just like Plasma is now, but any application. So I think in future it'd be very, very plausible to have one, for instance, Okular, where it has the same desktop UI that we know today, although done with perhaps QML desktop components, so it will look like it belongs on the desktop and is themed properly. But then when we put that switch, it would move to the touch active base. That's really cool, because it means we'll be able to take the device, move it, and have the application content move as well. So we're edging our way to that. Not only trying to divide our applications into works for touch, doesn't work for touch, which we do now, but we want to go even further and say any application that wishes to, or that it makes sense to, can actually shift and adjust their UI dynamically. Cool. I think that was all of the interesting questions. Well, interesting questions. It implies that there were non-interesting questions. There weren't. It was all pretty good. But we're at about an hour right now. And so Daniel asked on that, Daniel Nicoletti, that would it be possible to have different, for different screens, like phone docked, HDMI having a media center, and phone having the phone UI? From the, if running off of one device and having multiple different form factor UIs presented simultaneously, very difficult for a few reasons. Now, there's no reason why we couldn't, for instance, and we're actually going to be doing this in Plasma Active 4, have the Media Center UI as well as the Active UI, or slide in a phone UI on the side of a tablet or on the side of your desktop screen. But to actually have one screen showing desktop and one screen showing Plasma Active, for instance, yeah, that's a bit more difficult. And we don't really have plans for that right now. Being able to take one device and switch it between different form factors. More importantly to me is being able to have each device that I have reflect its duty well without having to use different software on each device. And that's a slightly more practical and common approach. So, not that it won't ever happen, but there we are. Manuel asks, Tortosa says, he says, I wonder how we can even detect the device we're running on. Detecting hardware is not that easy. No, it's not. What we can do, however, is first, most devices will have a default home configuration. We don't have a lot of devices that are completely flexible, device flexible. I mean, a phone, a tablet, even today's laptops are pretty much welded as to how they're put together. We can tell what is plugged in. Do we have mice? Do we have keyboards, hardware keyboards? Do we have external monitors? Are we looking at a television versus, well, even that distinction is kind of going away. But even more than the device, it's also the context of the user, right? So I might be plugged into a very large screen with really nice resolution, and I might think that's just a monitor. I might also be plugged into that exact same screen, but I'm someone different, or I'm using it in a different part of my house, and I might say, that is a television. So there's going to be at some point, we will need the ability for the person who's using these devices to be able to communicate, saying, this is what I'm actually doing, this is my context. And we have a tool for that, it's activities. So activities are really about the entire context. The information you're looking at, which is something that we're getting pretty good at doing right now with activities, but also the context within which you're using things. We already can do lightweight things with this. Right now, for instance, I have a video and presentations activity where it turns off power management, so that no matter what I'm doing, my screen never goes off when I'm in presentations, which is, it happens fairly often if you just sit there and talk a lot, as I tend to do. So we can already do some small things like that. I think we'll need to take that to even further. So I think it'll be a combination of being able to auto-detect some bits of hardware, but then also being able to let the person teach the computer patterns. So K-Screen, which is the new upcoming multi-monitor system, what's neat about it is you basically teach it. When you plug in a new monitor, it tries to guess the best thing, usually just turns everything on. But then you can say, oh, no, just that monitor, not this one. When I plug this monitor in, I only want to see stuff on it. And then it remembers that actual hardware combination. And so even if you plug in another machine or another set of monitors, even if it has the same resolution perhaps, but it's different type of screen, you can have a different configuration set up. I think there's still room to go on that, but it kind of starts to show the direction I think we'll end up going in. It's not only the device, but also the context. But yeah, it's an interesting, exciting space because there's no one really, even now that we have Microsoft looking at it, and some of the free software groups are starting to kind of look at how can you do this device spectrum concept. There's no real solid answers out there, and I don't think a lot of the attempts that are happening right now really fully grasp the details involved in making that work well. Cool, I'm gonna do one more sweep of the feedback areas to make sure I haven't missed anybody so that no one feels left out, that they would. And I think we're pretty good. Well, thanks for everyone for coming out. There's another interesting, enjoyable hour for me, at least. I hope it was for you as well. Looking at some of the interesting things that are happening in free software. And I will see you all again next week. Cheers.